have come out. And in fact, we're kind of on the hour, so we might as well begin. So 2012, interestingly, this TechEd, there's kind of not as much information or energy around the storage technologies that were brought out, and really a lot of them were carried through from the launch of 2012. And I've been working on site at Microsoft representing EMC for the past 15 years. So working with all of the server groups and trying to get all of that storage infrastructure glue in place. And in that 15 years, I've been incapable of getting rid of my Australian accent. So my background is from Australia. So what we're going to talk about through the session are these things. So ODX, right? I'm kind of interested. Has anyone implemented ODX functionality in their environment? No one. Awesome. So ODX is a great enabling technology for data movement, and we'll look at it. Wanted to give you a bit of shock and awe in terms of what that thing can do. Then we're going to talk about, so ODX itself is incompatible with storage spaces, so again, one of those areas where we're not going to see commonality. Thin support. So these are new standards that were brought out with Windows Server 2012 that were implemented, and now Windows Server itself understands that a device is thin and can execute special commands against it. So these are T10 specifications. Windows Hyper-V came out with a new storage, and so we'll look at a new storage model for virtual hard drives, and this is the VHDX implementation. And that has some special interactions with some of these technologies. So we'll look at kind of it throughout the demonstration, some of that functionality as it traverses kind of the VHDX and out to the storage array. Virtual HBAs, so a synthetic driver within the VM to externalize storage, to be seen as an external storage connectivity. That's fairly straightforward. There are a couple of gotchas there. There was an enormous amount of work done around storage management services, and this comes as a feature within the product, and we'll look at a little bit at that. There were comments made about the fact that customers implement a number of storage solutions. EMC in our product may be only one part of that mix. And so standards-based storage management gives you the ability to abstract away some of that uniqueness, but interact with multiple storage devices in a Windows-centric view using Windows tools. And that functionality is actually being brought out in the context of virtual machines in System Center Virtual Machine Manager. So we'll touch a little bit on that, but we've been talking about SCVMM 2012 for a while. So we'll look at it in context of something that is useful for customers, and that's delegation. So being able to provide the connectivity and the storage infrastructure, and then letting people do a self-service model in that space. So ODX, offloaded data transfer, right? This is about enabling efficiencies in the infrastructure. Why do we talk or use ODX? We generate an enormous amount of data. And by and large, we transfer a lot of that data around in the data center. So ODX is a mechanism to optimize the infrastructure and push that heavy work off into the array and let the storage infrastructure take care of it. We move a lot of SQL Server database environments. Interestingly, it wasn't an area that I specifically was considering when we were looking at ODX, but that tended to be the number one scenario for a lot of customers. There were people that were copying backup sets around in their infrastructure, sitting there waiting for up to an hour for that copy to get transferred. Virtualized environments as well. We are shuttling virtual machines, whether that's deploying templates out of SCVMM, whether it's doing a storage migration now within Windows Server 2012. All of that stuff requires resources. if we consider what we have in the world of copying prior to Windows 2012, that was a lot of read and write activity. So you were reading all of this data up from the storage device, presumably moving it to another system, so now congesting the network infrastructure, and then writing that down. In a SAN environment, that typically could mean that the source and destination were different LUNs on the same storage array. So you're shuttling all of this data, consuming resources when you didn't need to. So this is a mechanism to mitigate that experience and to optimize. So how does it get implemented? So this is a new feature that came out with Server 2012. It was a new specification. So there was a new SCSI code page that needed to be implemented. As a result, if you've got old systems that have been around for a number of years, it's likely that they don't support an ODX environment. But the storage vendors, by and large, are updating the firmware in their devices and providing support. It is detected by Windows Server when it does device discovery. So there's a little bit of dialogue that goes on between the server and the storage device to figure out whether ODX is supported. Once it does that, ODX gets dynamically invoked within the environment. So any operation that tries to use the Windows Copy API by default, so a drag and drop, a Control-V, Control-P, some of the deployments get invoked, whether the copy is within a LUN, across LUNs, or across an SMB connection to a different server that has an ODX-capable device. And then there's the opportunity for third parties to create these copy engines. And there's this concept of a copy engine. It's kind of important. We'll be talking about some of the requirements later on. But this concept of a copy engine. An engine is something that has generated that ODX request. In effect, if we think about an SMB share, the source and target kind of communicate. I've got an ODX-capable LUN. Do you? Yes, I do. Okay, I want to generate a token. So this is a representation of the data of the file object itself. And Windows is doing the mapping of, okay, so that file is actually a LBA address range. And so it figures out what it is. It generates a read token. The token gets passed to the target. The target uses the token and says, I want the device to move that data for me. And that data is moved internally within the array in, we don't really have a name for it, it's chunks. So it depends on the implementation of that functional area as to how fast this process is. So we're going to do a little bit of a demo. So people that saw last year at TechEd, there was a demonstration for ODX. People see that? We kind of did that was done on one of our storage arrays. It was 1 gigabyte a second. That got a round of applause. It's a bit of shock and awe. Our engineers have been hard at work and they implemented this functional area and did an awesome job. It's not me, it's them. So let's have a look. So I have a server. I have a number of CSVs within it. So it's a cluster. I am also, you'll see me capturing a lot of performance monitors. People like to see what's actually happening and that, in fact, we're not telling lies. So we're looking at total average bytes per transfer, total reads and writes, and even processor time. So I have a source file. This is generic data, 600 gigabytes. Copy API, copy, and I paste. And when we saw 1 gig, we're now doing in excess of 25 gigabytes a second of data transfer within the storage infrastructure. This data is being moved from source to destination within the array. No reads and writes are being executed beyond those that are required for the ODX operation implementation. So 1 gig to 25 plus gigabytes a second. So the graphs show that there was minimal transfer, just the reads and writes within the system. We actually have a little bit of scalability within the system, and I wanted to demonstrate this concept of those copy engines. So I'm going to start the copy again to a different location and a second copy. Now I have 2 copy engines running. Now the aggregate throughput is the 2 of those, and we're doing about 30 gigabytes a second. So the point is that you can run copy operations, ODX, in parallel. They run independently. These are different instances of the copy engine. They interact. They use the same resources within the storage array. So, in this particular instance, that device maximally has a 30 gigabyte per second connection for this system. But we just copied over a terabyte of data in like 20 seconds. So that is the power of the solution. Minimal CPU requirements as well. So that server was doing really nothing. But what about SMB3? Because that was all local, right? Well, how does this thing look when it runs over a network connection? So we're going to do the SQL example. I have a local computer. I have a number of storage devices that are presented to that system. I have a backup ODX LUN that's ODX capable and a non-ODX implementation. And I have my source system. So this is an SMB3 share from another Windows Server 2012. So if I copy that file into a non-ODX capable, I am saturating my network link. And I've got a gigabyte a second or a gigabit interface, so I'm maxing out that at about 113 megabytes per second. That would take 35 minutes to run, right? Same file to now an ODX-capable storage device, and we're back to the space that we saw before, where we're doing in excess of 25 gigabytes a second, transferring all of that data across to our target, which is E, and then in SQL Server, we bring up Enterprise Manager, and we can start the restore process for that system because the data is already copied for us in about 20 seconds. So this is part of the value of this technology in a storage area network, right? That sort of capability is really going to optimize the experience for customers as they try to operationalize a lot of these implementations. Again, ODX kind of gets confused with virtual machines. ODX capabilities are a Windows feature. They have nothing to do with Hyper-V other than Hyper-V is a consumer of ODX services for the purposes of pushing out systems. There are some special cases, and we'll talk about them. So, yes?
If you want ODX to function, does it all have to have the same frame, or if you have 2 frames on the same fabric?
Okay. So the question is, if I do ODX, do both source and target LANs need to be within the same storage array? The specification does not say that that has to be the case. But in the first iteration, I think you're going to find that universally the storage vendors are going to implement the condition that it does need to be within the same storage device, right? It gets really complicated when you think that you've got a storage device associated with another storage device because there has to be communication between those 2 storage devices. So pushing it through is going to be complicated. There is work in progress to make that happen. So the interesting thing about ODX is that it can be dynamically invoked and it can dynamically fail. I like to think of ODX as being a benefit and not a right. So at any point, the storage device could say, that's it, I'm opting out. I'm too busy, I've run out of resources, there's something that isn't right, and it can terminate ODX. Windows will detect that ODX has failed and will pick up the copy at that last known chunk, right? So we talked about the fact that it's transferring data at the back end. So it knows what that chunk size is. It knows when the last chunk was fully copied. So it kind of knows what we've copied so far. It can pick up and fall back into legacy copy. So now it'll just start doing read-write for the remainder of that copy. Now, we talked about these copy engines, right? So if one of those copy engines has an ODX failure and it falls back to read-write, for the remainder of that file copy, it will continue doing that legacy read-write. It will also have generated, in the context of the copy engine, a 3-minute timer, and it'll start counting down. So until that timer expires, or until we finish that file copy in that copy engine, it won't generate any more ODX calls. But other copy engines could continue on, right? So if there was something unique to that particular file that caused it to blip, it would fall back to legacy copy, and then it would just, the others would continue. I cannot stress enough how valuable I think this KB article is. There's a hotfix in it. I would strongly, if anyone asks me, what's the first thing I should do when I'm doing ODX? It's install this hotfix, right? There is some functional changes that occurred to optimize the ODX environment. It'll get released in some of the roll-ups, but just install that. And there's an associated KB article that some additional functionality got pushed in. It's got to do with CSVs, it's got to do with virtual machines, and you can read that other section. But absolutely, why this isn't mandatory is beyond me, but definitely install that, right? So I was thinking of the things that I want you to walk away from here. First of all, SANs are awesome. That 25 plus gigabytes a second is a transfer rate that you're not going to see in a great deal of environments. The second thing would be install this ODX hotfix. So, ODX controls. There's ways to turn this stuff on and off. So the arrays obviously might have capabilities of saying, you know, I support ODX or I don't. But you as administrators can also do it. Unfortunately, the granularity isn't that high for a system. It's either on or it's off. There is one condition that you need to be aware of. Volumes can be opted out of ODX copy operations. And this happens when there's a filter driver assigned to the LUN. It may be on the NTFS volume that doesn't understand ODX. And a classic in this space that we've run into is antivirus software. So old antivirus software doesn't understand what ODX is and just says, I don't know what that call is all about, but it's not happening here, and I've got control. So update and check release notices for antivirus software. If you absolutely don't want to have ODX, there's a registry key, and you can do a set item property from PowerShell admin console and disable ODX and turn it on. I've included a reference. There's a TechEd article that talks about the functionality of the enable and disable, and so you can go to that TechEd article and get additional information. So we talked about the fact that there was some integration with virtual machines, and specifically VHDX. So there's a special ODX operation, and it's called a write using zero token. So VHDX, for those of you hopefully familiar, this would be the third thing, use VHDX. So VHDX is a new virtual hard disk format that came out with Windows Server 12, does a lot of things, but it implements a number of special use cases, and we'll talk more about it as we go through some of the other areas. But this, write using 0, tries to initialize the storage allocation, right? So to make sure that if anyone attaches to that VHD and does a read, a raw device, they don't see anything but other than zeros. So we write a special token. So now some smart storage arrays, EMC, might take that and say, you know what, if you're on a thin device and you're trying to write zeros, let me just do an unmap for you. Because at the end of the day, if you've unmapped, we guarantee that we're going to return zeros. And really, that's the goal of that operation. So it initializes, and it's very thin friendly, and we're going to talk about thin in the next section. One other area that it gets implemented, storage migration. New feature in Windows Server 2012 for virtual machines allows you to reallocate a VHD to a different location. This isn't tied to VHDs or VHDXs specifically, but ODX gets invoked to do the bulk of the transfer, and then you're away, right? So some special use cases specifically around VHDs and VHDXs. You know, there's one area that kind of a lot of people go, really? System Center Virtual Machine Manager, right? This is all about deploying virtual machines into the area, into the environment. The one area that it doesn't support is understanding ODX. So when you have something like a template in a library and you want to push that out, it's pretty much hard-coded at the moment in System Center Virtual Machine Manager 2012 to do that using bits. So there's no checking, is this source and target, can I do ODX? It doesn't do that. It looks at some other functional areas, but it doesn't do ODX support. But there's ways to work around it, right? We have a PowerShell ecosystem within System Center. And so I wanted to give you an example of what we can do to push this stuff out. So this is a VMM server. I have my library, and in the library I have a VHDX that represents a sysprepped image of a Server 2012 instance. And so this guy is sitting somewhere in my library, and it's about 9 gigabytes in size. It grows up to, so it's a dynamic VHD, it grows up to 70 gig. Within my environment, then, I have these clouds. And I have one in particular, this Dev QA cloud, and that cloud uses a number of servers. So in my hosts area, I can see Cloud 2 servers. So Dev QA cloud lives on my Cloud 2 servers. So there's 6 servers in that environment. They're clustered, and at the moment, there's one virtual machine sitting out there. It's not really doing anything. But what I wanted to show you was using PowerShell to push the templates out, and then using ODX as a mechanism. So a bit of PowerShell. Did I tell you you're going into PowerShell? I have set up some arrays of the hosts that I'm going to do, the locations where the VMs are going, and then I'm going to push out 2 VMs per server, right? I have to do some pre-work to set up authentication, but then I'm going to run this invoke command. I'm actually going to push the work out to the servers and get them to get the data, and it's going to execute this exec block. And this is just the PowerShell script that gets pushed to the virtual machines. Essentially, it's just figuring out where it's going to put the virtual machine. It needs to create the location. On line 23, we copy the VHD, ODX. And then line 24, I do a new VM, right? So we're going to invoke the virtual machine creation. So let's run that. What we're doing is we're submitting in parallel to each of those 6 servers the requirement for it to go off and deploy 2 VMs from a template in the library using ODX. And we do that because we're doing a copy. So I'm showing the network counters for the system. This is the only way that bits could ever transfer those files. It's just a way to show you that we're not pushing this stuff over the network. So 6 servers, 2 VMs, 90 gig each, or 9 gigabytes each. We're pushing out around 100 gigabytes of storage across those servers. When this job completes, what it's going to do is return the runtime. And the runtime was not just how long ODX took, but the whole execution. So in 45 seconds, we deployed 12 virtual machines out into the environment, and then we instantiated these virtual machine instances. So if you wanted to do ODX rapid deployment, that capability is possible. You can't use VMM itself, but you can extend the value of VMM. And there's a way to go beyond it, right? And so this is just one of those virtual machines. I didn't start them because that runtime then looks 45 seconds. That's a lot of time. It was mostly in the creation of the virtual machines. So that was ODX. Great functionality, real value proposition for people that need to do rapid deployments and rapid movement but want to do it efficiently. I have to say that this is probably the most valuable functional area for a lot of customers. We've seen the adoption of thin storage support pretty much everywhere, and the ability for thin devices to be understood and discovered by Windows is invaluable. So we use thin devices in our environments because typically there's a lot of white space. Space that's allocated into LUNs that isn't used. It's capacity that prevents us from having to go out and add storage or do whatever. Prior to Windows Server 2012, NTFS had no concept of thin devices. And so what we would run into is a situation down in the bottom represented by the graph. So for the first part of the life of the LUN, the allocations as we add files kind of looks like the growth path of the allocations in the thin pool. But as we add and remove files, NTFS would go on this adventure of allocating new, previously unallocated space. So if you looked at NTFS and you said, how much is my utilization? It would plateau and it would stay fairly consistent. Files were being added and files were being deleted. And what was happening was when you deleted a file, it was unmapped or unlinked in the file system. And when a new file came up, maybe some of that space was used, but then net new free space. So what you'd find over a period of time, how long that is kind of dependent on the workload, you'd do a full allocation of it. Not really efficient and undermines the benefit that most people were looking for thin pools to give us. So introduced in Server 2012 was a new specification, so a T10 standard. So this kind of falls in the same category as ODX, where there was a new requirement for a SCSI octal so that the device said, I can support thin, and here's some other information about the storage device. So again, similar to ODX, if you've got kind of storage infrastructure that predates 2012, then high probability that this functionality isn't there because the specification only came around with Server 2012. It gets invoked automatically. So now when you delete a file, Windows will know that that storage device is a thin device. It knows the LBA address range that that file had in the file system, and then it will go off and execute unmap operations against it. So dynamically invoked. There are some areas where you can do that without it being dynamically invoked. So there's an optimized drive pane. It's actually built into the demo as well. And then an optimized -drive PowerShell commandlet that you can run independently if you wanted to schedule it. Unmap is also built into an NTFS volume format. So when a new file is initialized and you lay down a new NTFS volume, you will see unmap operations against, well, you won't, but the array or the storage device will see unmap. And it really is about optimizing that whole experience. Now this can take quite a lot of time, so I've trimmed this session down, and I'll tell you where it's trimmed. So, host with a number of thin devices in the environment, 3 that we're going to look at, and I've got a little utility that's going out. There's a backing store for any thin device, and that's the thin pool that it's coming from. This graph will update every 15 seconds, and what it's doing is it's showing us the allocations against that pool. So it's currently sitting at about 1.3 terabytes of allocated storage out of the pool, right? These 3 LUNs are just parts of it. I showed you the ability to disable ODX. There's a way to query ODX as well. So I'm going to disable ODX, but first you can check it. That filter supported feature mode is set to 0 here. We're going to disable it because I want to force you to sit through a copy operation so you can see that allocations occur. So I disable ODX, and then I'm going to take a 200 gig VHDX file that I've fully allocated. It's got data content, and I'm going to push it out onto my third thin volume. So copying 200 gigabytes. ODX is off. We're going to do legacy read-write. Very tedious process. That's going to take me an estimated, this will tick up, and it's about 35 or 20 odd minutes in reality. So I've accelerated, so reality has been distorted here. Time is going by very fast. This copy operation has been sped up. In fact, I needed to trim out some of it because it takes so long. So what we're finding is that allocation from 1.3 terabytes is going up to 1.5, as you'd expect, because we just copied 200 gigabytes of data. So the allocations, if we were doing ODX, what you'd kind of see is maybe some of this would be disconnected, that the allocations would continue beyond it. But then we plateau at that allocation, right? Now, previously, if I deleted this file, nothing would happen. Happily, with Windows 2012, if I now delete the 200 gig VHDX, and you can see that our graph is kind of plateaued, I get rid of it. Now an asynchronous operation occurs within Windows. Windows goes by and detects that the file has been deleted and now talks to the storage device and says, you know, you can unmap this range, and now you can unmap this range. And what you'll find is we go from that 1.5 terabyte allocation from the pool back down to our 1.3. So we've returned all of the space that we allocated. It happens behind the scenes. It happens automatically. We don't have to do anything special beyond have thin devices. And that works for virtual machine infrastructures as well. So here's a virtual machine. It's running Windows Server 2012. It's actually running on this host that I'm monitoring all of this activity on. And here's that VM. One of those other thin LUNs had a VHDX file. So I'm going to attach a virtual hard drive, so VHDX, that's out on one of those storage devices on this physical server. So out on F, I have a 300 gig file. So this, and it has to be VHDX, right, for this to work. So I attach the 300 gig VHDX file. I'll get out of Hyper-V Manager. We're back to the remote desktop for that system. Now, to see that device, it's a new device to this operating system instance, and so what we'll see is an offline device. I online it, I see that as a local storage device, and it's mounted at E drive on this virtual machine, and so if I go into that device now, there's my backup file. That was a file that I copied for that SQL example. So now, within the virtual machine, I'm going to delete this file, which is about 226 gigabytes. The file delete within the VM is mapped to the VHDX, and the unmapped calls are passed through to the parent and through to the logical unit that's out on the array. And so what ends up happening is that we deallocate all of the space that was allocated for the file in the VHDX. And from externally, so that takes a period of time. Again, you can see there were time intervals that you can monitor, and you can count the little dots. Why is it not instant? Just before we do that, I do want to go into this. So there is, for every device, actually, let me pause this. So why is it not instantaneous? It has to do with how Windows is scheduling the unmap operation. So it's an implementation details within Windows and NTFS specifically. We'll talk a little bit about some of the things to be aware of. But it's run as a background task so as not to get in the way.
It's not like going through all the X and having to arrange X instead. Is it going log by log?
So the question is, how is it implemented? But there was a reference there to ODX. ODX has nothing to do with unmap. But the implementation, it's a lot more detailed. We can go into the minutiae, but there's a communication, and in the same way that we transfer in chunks with ODX, well, we can unmap in chunks for thin devices. And it really is that communication. The maximum for the unmap operation is 24 megabytes. So in a single unmap, it can't do more than 24 meg. So if you've got a 220 odd gigabyte LUN, that's going to be some number of cores. Okay, all right. So we were talking earlier about the ability to do this optimized drive. So in the UI, if you select any storage device, you get an optimized drives view. And this tells you for any of those devices what the level of utilization with respect to, do I have orphan files, right? So did someone delete something from the file system that didn't actually release space in the pool? And at the moment, it's at 100% space efficiency, right? So you can vary it. You'll also see that there's capability to control a scheduling mechanism around this. So there are a number of ways you can run it. It runs in band when it's on. If you wanted to check space utilization, perhaps you disabled it for some reason, and then you come back and you want it to clean up what you just did, then you can run the analyze and do the optimized drive as well. There is also the PowerShell, so if you wanted to do it. So operational behavior. Well, we just saw that unmaps work with VHDXs. That was that third point, right? Move to VHDX. There's a lot of reasons beyond just the functionality of being able to do unmap and ODX calls in VHDXs. There are alignment issues. There's performance. Lots of great reasons to go. Things to be aware of. There is a degree of serialization that goes on with unmap, right? We talked about the fact that there is this chunking of those deallocations that occurs over time. And some of that can get in the way of certain operations. For small files, every file delete could generate an unmap. So some of that, there are certain instances where that can get in the way of other behaviors and take a great deal of time. There are updates that occur to NTFS that might have to wait. And for all intents and purposes, your experience will be that suddenly something that you're doing with that LUN just kind of hangs. There's no real indication that there's unmap operations that are going on. If you were to look at the connectivity to the device, network connections if it's iSCSI, the fiber channel interface if it's a fiber channel connected device, it will kind of look like it's stalled, but you'll see a trickle of unmap operations. No software is fault-free, right? There are lots of examples where fixes come in. And we have a hot fix coming out specifically to improve the overall experience, where it parallelizes a lot of this activity. So it's not currently out, but hotfix 444333. Very easy to remember, right? And if someone was in terms of it's not available at the moment, it's coming out later this month. We've validated that it does what it says it does. Watch for 444333 if you're doing thin. And that's going to improve the overall experience for utilization of it. But extremely valuable, right? We want thin devices because it gives us a better return on investment for storage. We've seen the power of it. It does it all in band before we had to go to extenuating circumstances and go out and do all sorts of things to unmap. This too can be coordinated. You have a degree of control. Again, the array may turn it on or off for particular devices. In this case, thin is controlled by FSUtil. So there's a command line interface to FSUtil, and you can do a behavior set. And it must be software developers, but you enable the disable, delete, notify, and that turns it off, right? So if you want to disable unmap, then enable, disable, delete, notify. To enable it, then you disable and notify. So in any event, so you can turn it on or off. It is dynamic. So as soon as you do it, unmap operations will stop, right? So this isn't a reboot of the system or anything. So throughout the demonstration, we kind of talked about it. Again, VHDX format. I can't tell you, beyond those other things, how valuable VHDXs will become for you. All of the advanced functional areas are getting implemented in VHDX. VHD format was good at the time, but it's kind of moved along as well. So Unmap and ODX work into VHDX environments. There's also this concept of a virtual HBA. So this is that synthetic driver that's added into a virtual machine and can make it look like it has its own HBAs. So really in this space, it makes it look like a physical server, at least as far as the storage area network is concerned, right? You're going to have to do some masking and mapping and zoning and all of that good stuff. The only thing that I would give you as a word of caution here, a problem that people run into is around live migrations. So when you implement a virtual HBA, you have two address sets. There's address set A and address set B. And what happens is when the system is activated first, address set A comes on. And so if you're out into the fabric and you're doing zoning, you'll see it and you set it up. And life is great, everything works. And then you do a live migration. Well, during a live migration, what ends up happening is that second address set, the interface comes online. And it tests to see if it can get to that storage device. If you haven't set up zoning for it, that's going to fail. And so what will end up happening is you'll try to do a live migration, it'll look like it, oh, bang, and it'll come right back, right? So beware of the duplicate, the two sets of addresses, and make sure that you appropriately deal with that for zoning. But beyond that, it makes it look like it's a physical server. You get direct access performance. Life is grand. A new feature, this is kind of the silent killer in Windows. I think it's great, a lot of value in it, but I don't know that a lot of people. Who even knew that there was the standards-based storage management feature within Windows? 1, 2, 3 people. Wow, I wasn't expecting anyone. So in Server 2012, a whole bunch of work was done around Windows standards-based storage management. So this is a way for you as customers to kind of abstract away the uniqueness of all of these different storage infrastructures and just deal with them as entities and do things generically across them. So it's a Windows feature. You just turn it on and it gets installed, and it has support for the storage spaces, storage provider, and it also supports a number of other environments, and for us in the storage land, typically that's SMIS, right? So it provides a standard way to get in and talk to the storage and do stuff with it. So we've had lots of examples, and so another video. This is really all about PowerShell. Hopefully PowerShell isn't putting the fear of God in anybody. There are essentially two modules that are involved. There is an SMIS config module, very simple, has 3 commandlets in it. So if I look at the get command for the module, you'll see that there's a search feature, there's a register and an unregister. So this is about SMIS target endpoints, and we'll see an example of connecting to it. The second module is the storage module. This does all of the heavy lifting. And here we see a huge swath of PowerShell commandlets. These are standard Windows Server PowerShell. These aren't from EMC or any other vendor. These things allow us to interact with those storage management services, right? Everything from masking operations, which we'll see, down to the simplest of things like get volume. So what volumes can I see on this system, right? And here they all are. We can look at the storage providers that are accessible to the system. So we do a get storage provider, and that's going to list the registered providers. One of them is storage spaces, because that's built in. And the second one is an SMIS server that I set up that talks to an array that this system is zoned to. So we're going to turn into PowerShell, and we're going to go out and in a generic way talk to the SMIS provider to create a LUN for us. So I import those 2 modules, and then I'm going to go out to an array. So I have to tell it which array, and then I have to tell it which server I'm going to present to and what size, and go out and provide this information to it, right? Most of that top section is just setup work, and then we go through a number of those SMIS calls via our storage framework to go out and create a new virtual disk. So we're going to talk to an array from Windows and say, hey, I want a new virtual disk and I want it presented to this host. So we're going to go through the execution. So I set up that environment, goes out and defines what we're going to create and where we're going to create it. I connect to that provider. You saw that listed as one of those providers that was registered. From the provider, I can have one or more storage arrays, so I have to define which storage array I want to talk to. I get a storage pool. I'm creating a thin device, so there has to be a backing store somewhere. So I get the pool. I get a masking set because I'm going to present the storage device to a host, and our interfaces know how to deal with masking. And now I'm going to go off and create. So I'm just doing a generic call of a Windows new virtual disk. It goes out, connects to the array, selects the storage pool, says, hey, I want to create a 44 gigabyte LUN, and then it returns that object. The final thing that I have to do is make it accessible to the host. And this is a masking set operation. So I tell it to present that device to this host. It goes out and it executes. That is completed. This is a remote desktop to that environment. I'm not going to see the new device until I do a rescan. So the device is added, but the UI needs to be refreshed. And there's my 44 gigabyte device. And I did not use a single EMC tool to do that. So whether you wanted to use storage spaces, a third-party storage array, EMC array, someone else, as long as there's an SMIS provider in there, you could run the same script, provide the same functionality, and get it done. So you don't have to get yourself involved, even in vendor tools. You can generically interact with storage devices. We've done a lot of PowerShell. It's kind of cool. But a lot of people want to do much more dynamic things. And in this space, it's all about Orchestrator. An orchestrator is a mechanism to create these things called runbooks so that we can run these operations time and time again in a structured way, and then we can link them with other products. So we're going to dive a little bit into Orchestrator. People familiar with Orchestrator? Most people. All right. This is not an in-depth session about Orchestrator. I'm just going to show you some very high-level stuff. Your interface into Orchestrator is through the Runbook Designer. And the Runbook Designer allows you to create, effectively, workflows. There are these things that you can find and download. They're called integration packs. They provide higher-level activities that people provide. So System Center Virtual Machine Manager has more knowledge about things that System Center can do. In general, though, you're going to start with something. I'm actually using, in this case, an EMC integration pack that understands the concept of storage and these things called LUNs and hosts. And so I could replicate what we did in PowerShell through the construction of a set of sequences, right? So I want to create a LUN, I want to present a LUN, I want to initialize it, and then I link those things together, right? So at a high level, that's what I do. I actually have the create LUN script. This is doing a little bit more. It's connecting to the host. It's actually creating the new LUN, presenting the LUN, initialize, format, disconnect that host, and get the heck out of Dodge, right? So go in and do this work. So the initialized data actually gets a lot of that information that we had in our PowerShell. What pool do you want? Which array? Which pool? What size? That stuff, those results, get passed through the data bus. And then they get consumed by these devices, these steps as they execute. There's a runbook tester that allows us to have a quick view of what this thing does. And in effect, when we execute it, it's going to ask us for that input parameter, and then it's going to go off and run. So which host do you want to present it to? Well, my host name is RTC_server_3. Which array are we going to try and do? This is one of our arrays that's connected into this file environment, a 60 gig. I have a pool out there called Hyper-V, and I want to create a new LUN, call it my new LUN, right? And then that's it. So the parameters have been passed to the script, and the script goes off and deals with the interaction for those devices and goes off and does what we need it to. So it's created the LUN. It's presenting the LUN to a host. Again, here's our remote desktop connection to that system. This is actually a sequence of steps that goes further than we did previously. So at the bottom, it's going to turn up as disk 13. There's my LUN. And my next step was to initialize it. And then I told it to format it. So it's going to format that device and give it the name that I specified, and it's gone off and executed. Now, kind of interesting in terms of you can create this runbook, but the real goodness comes when you think about what that means to you. So rather than sitting around and waiting for someone to tell you, hey, I need a new LUN, and then you going through the process of doing it, you can instrument a runbook through either Service Manager or some other mechanism that the user requests a storage device, it gets logged, you approve it, and then this runbook executes, right? So think about it in terms of the value proposition of extending the business process. So you don't have to go through the mechanics of doing it. We heard earlier in the keynote that getting people involved results in elongation of processes and the possibility of getting it wrong. So the less hands-on time, the better. So Orchestrator is an area that vendors can extend and provide value. One other area that we've kind of extended, we did that SMIS stuff. The first consumer of the SMIS service was System Center Virtual Machine Manager, and it's cooked right in. So Virtual Machine Manager is all about that private cloud. It looks at the physical servers, it's concerning itself with the storage that's allocated, it tries to manage the virtual machines, it does deployments, it does a range of activities. They also want to automate and orchestrate all of the storage devices. So in Orchestrator, or in Virtual Machine Manager, we have a lot of those same features that are presented in the context of Virtual Machine Manager. So we go to Virtual Machine Manager. This is our fabric view. So this is our storage infrastructure. We can look at a number of activities or of areas. So we have this provider. That is the SMIS provider that we were talking to. So that's exactly the same endpoint that I was using in the PowerShell script. This gives us the capability to understand arrays that are sitting behind the provider and abstract them in the same way that we did in the script. So I can get information about what that storage device looks like, total capacity. If I have multiple arrays that are sitting behind a provider, I can look at those and get aggregated information. But more interestingly, we have this concept of managed pools. So these storage infrastructures can get busy. What I can see are those pools that have been defined by the administrator as being under my control. And I can look then within those pools or those storage allocations of everything that I'm entitled to view, but nothing that I'm not entitled to view. I can then classify that storage, and then I can take those classifications and propagate them into other entities, right? So I have these storage classifications of pools behind a provider. We talked about those servers. We saw Cloud 2. What we can do for a collection of servers is we can define what storage pools can be allocated to it, and subsequently what storage those servers can consume. We have a higher level functional area called a cloud. A cloud lives on servers, so we propagate that information up. And so my dev QA happens to consume the resources of that Cloud 2 server pool, and as a result, when I look at the storage, I see the pool that I was given permission to and none of the others. One level of higher abstraction. This is tenants. And here we see the real value. So now I have the capability for a particular tenant in my private cloud environment to limit their scope. So these guys only see production. And from that production pool, they can consume this amount of resources. So as long as they stay within the resources that I've told them that they can consume, they can go off and do whatever they need. And I need not be involved. So within Virtual Machine Manager, there's the ability to create virtual machines, create LUNs, to allocate storage, and you can delegate out. An administrator can go off and consume these number of resources, and as long as they stay within it, that's the only view that they have, and they can't cause chaos to other consumers. And so they can coexist with other systems. And in terms of providing value add, that abstraction from the storage infrastructure, layering on business processes, and then there's a front end, and we didn't really talk about the ways that you can interact. People have seen the hosting stuff or Project Catal or even application controller. There's a way to interact with them and stay within the framework that the Virtual Machine Manager admin provided you. So overall, Windows Server 2012 is a very extensible environment, right? So there's a lot of power that we can consume. Hopefully you had a wow moment with 20 odd gigabytes a second. I'm not really sure that you're going to see that anywhere else, but if you do, let me know. So there is a lot of value for storage arrays. I know that there's a lot of talk about expensive SANs. And I like to think of it in terms of an analogy, right? So if you think about cars, there's a whole subset of people that are really happy with a little smart car. And then there's a subset of people who have, the 3 kids and the dogs and the mountain biking and the hiking that need an SUV. The people that buy a smart car might say, well, an SUV is really expensive. And the people that buy the SUV go, you know what, I have all of these requirements, and that is cost effective for me. I think the analogy holds true for storage arrays in that there's a subset of people out there that need a host of functional areas and the value proposition that's represented, and so SANs are applicable. There is absolutely that section of consumers where that is not true. They can coexist. I think there's a spectrum of solutions. So, having said that, there's obviously ways that we can extend that environment. Storage vendors have a part to play. I would like to thank you, because that's the end of the session. We've hit the hour mark. There are other resources that are available, the usual thing. So thank you very much for attending and staying. Don't forget ComNet and evaluations, please. Thank you.